Hello good dear viewers. In this tutorial we want to prove this limit problem. We are asked to show that the limit as x approaches 3 of the function f of x exists. What does this mean? For a limit to exist, both the left and the right hand side limits must be the same. For example, if the limit as x approaches a from the left hand side of the function f of x is equal to the limit as x approaches a from the right hand side of the same function. If they are equal, maybe they equal to something else like L. If this exists, then we say that the limit as x approaches a directly without any sign of the function, the same function, also exists and what equal to L. So if you are asked to prove something as x approaches 3, you should evaluate the limit as x approaches 3 from the left hand side. Also evaluate it as x approaches 3 from the right hand side. If the two values are the same, then the limit as x approaches 3 also exists. Otherwise, it does not exist. Okay. Let's use a number line. We are talking about 3. If you approach this 3 from the left hand side, it means all the values of x to the left hand side are less than 3, because you could obtain 2, 1, 0, -1, all these values, because you are approaching 3, they are all less than 3, all these values. But the moment you approach this 3 from the other side, all the values are greater than 3. You know, we have 4, 5, 6. If you're coming towards 3, all those values to the right hand side of 3 are all greater than 3. Okay, now let us evaluate the limit as x approaches 3 from the left hand side. The limit as x approaches 3 from the left hand side of the function f of x equal to, since we are approaching from the left hand side, we know that values must be less than 3. Then you look at this condition. This is a piecewise function. It means what? The function is equal to the square root of 25 minus x squared when x is less than 3. And the function is equal to 2 exactly where x is equal to 2. And the function is 2x minus 2 when x is greater than 3. So we are evaluating the limit as x approaches 3 from the left hand side, meaning we are considering values of x less than 3. And you can see the condition here, the intervals. This is exactly where x is less than 3. So you use this function. It will be the square root of what? 25 minus x, which is 3, squared. 3 squared is 9. 25 minus 9 is 16. So this is equal to the square root of 16, which is equal to what? 4. So we have seen that the left hand side limit is equal to 4. What about the right hand side limit? We want to see whether they are the same. So the right hand side limit as x approaches 3 from the right hand side direction, the moment you approach 3 from the right hand side, x must be greater than 3. So where is x greater than 3 here? This is that. You see x greater than 3, so we are going to use this function. It will be what? 2x, but x is 3 minus 2. 2 times 3, 6. 6 minus 2 is equal to 4. Oh, you can see that both the left hand side and the right hand side limits are equal, 4 and 4, which means what? Therefore, this implies that the limit as x approaches 3 of that function f of x exists. It exists, and it is what? Equal to 4 as well. But if this value is different from this value, the limit does not exist. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.